So this window is for TechWiz DB, and let's see this part. And there are 6 types of DB modules: material, layer, light source, signal, grayscale, and TFT model. So if you just click a particular DB material, for example, I want to see the BM property. So the property of the BM is showed up in the information window, and you can just check on other tabs as well. Also, if you want to modify the parameter, for example, if I want to change 11 to 10, just enter it and click Save button, and there is a message. Do you want to replace it? If you want to, click Yes, and if you don't want to modify it, click No. So in this case, I will click No. And let's see another material DB like this. Also, one of the most important things to utilize it is creating a new DB. Just click this New button and define this information. So, for example, just enter the name and saved path, and then select the item, and also select the detailed type like this. However, the parameters to be input are a little bit different by each module and material type. So let's check them step by step through example materials. At first, let's see the material DB. And let's look at the example starting with LC. I will see the LCTN. So if you double click the LCTN, there are 2 tabs: electrical property and refractive indices. In the electrical property tab, you can enter the values for the electrical properties of LC, such as dielectric constants, resistivity, elastic constants, and so on. And flow viscosity and lossless coefficients are used for the flow solver, so normally you don't need to enter them. Also, if you check the blue phase type, it means that you want to analyze the blue phase LC. So in this case, please input the curve constants. Go on to the next tab. In this tab, you can set the values of refractive indices of LC. To enter the values, there are 3 types of methods: constant, Cauchy's formula coefficient type, and wavelength type. So if you already know the constant values of NE and NO, click constants and enter them. As an example, I will input 1.55 for the NE and 1.5 for the NO. However, it is not the end. When entering the values in the refractive indices tab, you have to click this Make Table button. As you can see, the information that we entered is showed up like this. Also, select the wavelength step here. If I select the wavelength step as 10 nanometer step, it means that it has the same refractive index from 380 to 780, which is the visible light range, and the step is 10 nanometer. And if you want to enter the coefficients of Cauchy's formula, click like this, and I will show you the example. I prepared the information like this, so I will just copy and paste the data. Actually, I have no information about A4, so just skip it. And before I already mentioned, but the most important thing to do is clicking the Make Table button, like this. So as you can see, by the user-defined values, reflective indices are calculated automatically. Lastly, click Cauchy's formula wavelength type. It is very similar to enter the values. I already have the information, so I will just enter them. Yes, I'm done. So let's click. So if you click the Make Table button, and the information of NE and NO is automatically calculated by the wavelengths and NE and NO conditions. Also, if you already have the measured data from the Excel file, it is also possible just copy and paste it like this. So you can utilize this information as well. So far I have talked about LC, and the next one is the insulator. And next one is an insulator. So for example, let's double click on oxide. There are two tabs, and since it has an isotropic material, it has only one dielectric constant, and resistivity value is only used for calculating the resistance. And the second tab is refractive indices. To enter the values of refractive indices, there are three types: constant, Zellmeyer coefficient type, and wavelength type. So when you know the constant value of n, click the constant. And if you know the values of a Zellmeyer equation, especially the coefficients, click the second one. As an example, I will enter like this. The most important thing is clicking the Make Table button, so let's click it. You can see that the n is automatically calculated based on the Zellmeyer equation. Also, wavelength type is the same, so I will skip. Therefore, even though the formula is different compared to LC, the method to enter the variable is totally the same. Just enter the values and click the Make Table button. So the next one is a metal. For example, let's double click the ITO. So if you want to calculate the resistance, enter the value as resistivity, and the second tab is refractive indices. This tab is totally the same as for the insulator, so I will skip it. And the third one is reflectivity. I made some slide for this tab. So you can use the metal layer as the reflector. The reflectivity function is added to consider the analytic reflection. As you can see, enter the reflectivity value between 0 to 1. So, for example, if you enter the reflectivity as 1.5, it means that the extinction rate is 50% and reflection rate is 50%. Moreover, if the reflectivity is 0, the extinction rate is 100%. So the incident light is perfectly absurd. And let's go back to the program. If you click Tools and Option and select Material, you can see this reflectivity checkbox. So if you uncheck this option like this, you can set 2 additional tabs for the metal layer. If the user who wants to set the reflection intensity according to the viewing angle, please uncheck this option. For detailed information about those 2 tabs, please refer to the manual. And the following one is a polarizer. As an example of the polarizer, let's double-click the polarizer. There is only one tab, Refractive Indices. The refractive index of the polarizer can be set as a real part and imaginary part. Defining the imaginary part of the refractive index is very important, so it should be entered. The rear part input method is the same as that of the insulator, as you can see. Also, you can select the extraordinary axis, x-axis or z-axis. And to define the imaginary part, let's click Imaginary. And there are 2 ways to enter it: constant and transmittance measured. So, if you know the imaginary part as a constant value, click constant and enter the KE and KO. And if you want to define it as the measured data for the transmittance, click transmittance measured and enter the thickness of the polarizer. So based on the user-defined transmittance data and thickness of the polarizer, extinction coefficients are automatically calculated by using this make table. So please input the exact transmittance data and thickness of the polarizer, and don't forget to click the make table button. And there are 3 options for entering the transmittance of the polarizer. The first one is default. Default means that we do not check any options like this. So when it is default, only the result of measurement with the polarizer, that is the surface reflection of the polarizer, is considered. And when checking the neglect surface loss, literally surface reflection is ignored. And when checking the substrate, a polarizer is placed on the substrate. So when measuring the transmittance of the polarizer, The transmittance can be entered considering the refractive index of the substrate. So by clicking the Set Refractive Indices Table button, you can enter the refractive index according to the wavelengths. Also, select the polarizer measurement method. There are two measurement methods, TE-TO and TS-TP-TC. Let me explain by looking at the picture. At first, TE. The direction of the incident light and transmittance axis are crossed each other, so the transmittance is very low. On the other hand, TO means that the direction of the incident light and transmittance axis are the same, like this, so it shows very high transmittance. As you can see, this TO is much higher than TE, and TS, TP, and TC means single, parallel, crossed, respectively. So you can choose between two methods and then set the wavelength condition here, where the transmittance is measured, and input the transmittance data. It is also possible to copy and paste the measured data from the Excel file. And after entering the data, don't forget to click the Make Table button. The used equation of converting is as follows. As an example of the retarder, please double-click the tab. There are two tabs, Electrical Property and Refractive Indices. As you can see, the input method is the same as an insulator, so please refer to the insulator type. But additionally, retarder type can be selected from uniaxial and biaxial. If you click uniaxial, you can enter NE and NO, but if you click biaxial, you can enter NX, NY, and NZ. And now for the color filter, double-click the color filter green. Also, there are two tabs, Electrical Property and Refractive Indices. The input method is totally the same as an insulator too, so you can refer to the insulator type as well. However, defining the imaginary part is also important, like on polarizer, so please enter the data very carefully. So it's the end of the explanation about material DB. And let's move on to the next DB module, layer DB. Single layer, group layer, multi-domain, and color filter layer can be created by layer DB. Single layer is composed of one material. Group layer consists of several single layers. Multi-domain is a layer divided by several single domains. Lastly, there are two types of color filters, RGB and RGBW. Actually, it is not essential to define a layer DB because the corresponding layer information can be set in the TechWiz program. However, if you define a single layer or a group layer for frequently used layers in advance, you can easily create a project. So, in this training, I will just give a brief explanation about each layer DB type. So, as an example of a single layer, let's double-click the TNLC. When creating a single layer DB, drag and drop the material DB first and then define the layer information such as thickness, the number of division, and optical axis. In this case, TNLC is a LC layer, so the thickness means the cell gap, and then enter the number of divisions. Normally, about 21 is entered. And next one is optical axis. For the LC layer, the optical axis means a rubbing condition. And there are three types of methods to set the optical axis: homogeneous, inhomogeneous function type, and inhomogeneous table type. Please look at these figures. Homogeneous means that the optical axis is homogeneous from bottom to the top surfaces. On the other hand, inhomogeneous is that the optical axis is inhomogeneous. And let's take a look at this pair. If it is defined in the z-axis on the x-ray plane, theta is positive like this direction. Also, if phi angle is defined counterclockwise on the xy plane, this direction is positive. Then let's go back to the program. Since TNLC is a 90 degrees twisted structure, so if you look at this table, the theta angle is 4 degrees and the phi angle is 90 degrees twisted from minus 45 to minus 135 degrees. When inhomogeneous is selected, there are two types, function and table. So if you select function, set the theta and phi angles of bottom and top surfaces, and middle area is automatically calculated by linear interpolation. And when inputting theta and pi angle data directly into a table, select inhomogeneous table. So you can check the LC distribution right away based on the angle data. It is very useful. I will show you some example. I will click function type and I will modify this phi angles, for example minus 60 to 90. And you can see the changed linear interpolation graph from minus 60 to 90, but it is not changed, so you must click make table button here so you can see the angle data like a table type. Also, you can see the LC distribution based on the user-defined values. Also, there are other tabs like this, but in this training I will not explain about these tabs, so please refer to the menu. And next is a group layer. Group layer consists of several single layers, and these icons are the group layers. For example, let's double click the VA. Depending on the types, stacked, multi-domain, color filter, RGB, and RGBW, different types of group layers can be created. So I will show you some figures of the group layer types. Let's suppose that I made 4 single layers, sample A, B, C, and D. And then if I choose stacked, 4 single layers are stacked along the z-axis. Also, if I choose multi-domain, 4 single layers make a multi-domain like this. And for the color filter layer, there are 2 types, RGB and RGBW. And let's go back to the program. So this VA group layer is a stack layer. So these 4 layers are stacked along the z-axis. Also, you can see that CFID and ratio term they are unactivated. So as an example of the multi-domain layer, please click the VA4 domain. You can see that the type is not stacked, it is multi-domain layer, and you can see that ratio term is activated. With the multi-domain feature, you can create a group layer in such a way that 4 domains with different LC layers share the same layer. So in this example, the area ratio of each domain is 1, 1, 1, 1, but you can change this ratio. Also, let's see the color filter layer. As you can see, the type is RGB color filter, and also CFID and ratio are activated. So, same as multi-domain, you can set the area ratio of each color filter in this term, but you can additionally designate the color property in the CFID. So, to identify the optical analysis, defining the CFID is very important. So please check again. For example, this one is for the red, so you have to set the CFID as R, means red. But if you want to change the color, just click it. And let's talk about the light source DB. In this DB module, Lambertian and non-Lambertian light sources can be defined. So please double-click the CCFL. As you can see, the uniform is checked in the viewing angle term. It means that it is a Lambertian light source with the same spectrum and intensity depending on the viewing angle. On the other hand, I will show you the non-Lambertian light source. So, the uniform part is unchecked. So in this case, you need to set the specific theta and phi angles for the viewing angle and input the spectrum data according to each viewing angle in the spectrum tab. So the first thing to do is entering the spectrum data in the spectrum tab, and then based on the spectrum data, the luminance data is also automatically calculated. So if you click the data table, you can see the automatically calculated luminance data. And the next one is a signal DB. For example, if you click a response, the following pulse is displayed, and as you can see, the voltage according to the time can be set and managed. So when you click the plus button here, the time interval is automatically added to the datasheet, and to modify the voltage value, please double click the data and then modify it. In addition, the desired purse can be implemented by using the function and range options. And let's move on to the grayscale DB. In this DB, you can set the transmittance according to the gradation level. And as an example, please double-click this one. By user-defined values as level and gamma, the transmittance curve according to the gray level is automatically calculated. And finally, there is a TFT model DB, but it is only for the full charge mode, so I will skip about this explanation. So we have discussed the method how to create and manage the DB materials. Next, let's talk about the TechWiz layout.